Hi, my name is Bahadur Ahmedov. In this video lecture, we are going to talk about the natural exponential function and its application to calculate the compound interest formula. So essentially, we've got some found and we're going to deposit this, invest this to the bank, and we would like to calculate how much money we're going to have after a long period of time, where the bank is going to calculate the percentages, the yearly interest, in a very complicated formula. So we're going to start talking about this topic. There was very simple one. So we're just going to talk about the interest formula in the beginning. So essentially, let's make a scenario. So you've got just $1,000 and you would like to invest this to the bank with a yearly interest 12%. 12%. What does it mean? That it means that after 1 year, you're going to get your $1,000 plus the 12% on the top of this. So let's write this down in terms of the mathematical formula. So it's going to be $1,000 after 1 year plus $1,000 times to the 12% of this. So in order to calculate the 12% of the 1,000, you need to multiply 12 divided to the 100 and multiply this to the 1,000. So essentially, this is going to be 12% of $1,000, and you can just get this from the proportions of the percentages. So what I would like to do now is I would like to take out this 1,000 and this 1,000 out of the brackets. So it means that I'm going to write down $1,000 here. So then I'm going to write down these two terms inside the brackets. What is left? So what is left if you just take out the 1,000 from here? Oh, you might say nothing, but there is something which is left here. So this is just simply 1. Because if you just multiply 1,000 to the 1, you are going to get this term, right? Plus 0.12, because 12 divided to the 1,000 is going to be 0.12. And again, if you multiply 1,000 to the 0.12, you're going to get the second term. If you add the terms inside the brackets, what you're going to get is 1,000 times to the 1.12, and this is going to be equal to the $1,120. So this is what you're going to get back from the bank after 1 year if the yearly interest is 12%. So which can be calculated using a calculator as well. But what is important for us is what happens, how we can calculate the amount of the money which we would just deposit this amount now. I'm not going to deposit 1,000 again, so I'm not going to get the money from the bank back. So I'm just going to redeposit this amount now. So if I would just deposit 1,120, then after 1 more year, the amount of the money which I would get is going to be 1.12. So essentially, if you would like to get your money plus some percentages, you need to multiply this to say 1 plus say 1.2 to the percentages number. So essentially, if it is 12%, it's going to be 1.12. If it is 10%, it's going to be 1.1, and so on. So essentially, in this form, you can just calculate how much money you're going to get after the second year, but which is more important for me to write this down in this way. So do you remember that how we obtained 1,120? So we obtained this by multiplying 1,000 to the 1.12, right? So here it is. So now we need to multiply this to additionally 1.12 in order to calculate the amount of the money which we can get after 2 years. So you see, so I'm multiplying 1.12 twice. So essentially, the amount of the money which I will get after 2 years is going to be 1,000 times the 1.12 and the power of 2. So which gives us the very much insight about how we can calculate the amount of the money which we'll get after 3 years. So the amount of the money which we'll get after 3 years, if you invest just 1,000, it's going to be a 1.12 in the power of 3, and so on. For example, if you would like to calculate how much money you're going to get after n years, then what you need to do is you need to multiply 1,000 to the 1.12 in the power of n. Okay, so this is very much similar to all of these things, but now let's assume that this is what does the bank A offers to us. So the bank A says that, hey, Just deposit your money to our bank. We'll give you 12% yield interest, which is like really nice offer. But let's say the bank B is going to tell us, hey, so I'm the bank B. I'm offering you again 12% per year, 12% per year, yearly interest. But what I would like to do is I would like to calculate your percentages in every quarter. So we call this as an interval, interest period. Interest period is going to be equal to the 1 quarter. What does it mean? It means that in 1 year, our fund is going to be calculated, our percentages are going to be calculated 4 times. So once after 3 months. So this is the first month. So in the beginning of the fourth month, it is going to be calculated once. In the beginning of the seventh month, it's going to be calculated twice. In the beginning of the 10th month, it's going to be calculated for the third time. And at the end, like at the end of the year, at the end of the 12 months, it's going to be calculated one more time. So 4 times it's going to be calculated. Okay, so 1, 2, 3, 4. So it appears I will get a different amount of the money if I would just calculate it in this way. So let's assume now, so if the yearly interest is 12%, okay, then obviously at every quarter, this 12% is calculated per 3%. So in the first quarter, it's going to be calculated 3%. So here's the 3%, and here's the 3%, and here is the 3%, right? Because in total, it's the 12%. So now, if you would just put 1,000, the percentages are going to be calculated every quarter, how much money you would get at the end. So let's calculate this, right? So after 3 months, the amount of the money which you get is 1,000 plus 1,000 times to the 0.03, right? Because it is going to be 3% of 1,000. So you can take out the 1,000 from the brackets. It is going to be equal to the 1.03, which is what is inside the bracket. So this is going to be $1,030, right? $1,030. So this is what you're going to have here after 3 months. So what you need to do is now you're going to deposit $1,030 again, and you are going to have plus 3% after 3 more months. It is going to be 1,030 times to the 1.03. It's going to be this amount plus the 3%. So let me calculate this using a calculator. So if you multiply 1,030 to the 1.03, what you get is 1,060.9. So this is what we will get after 3 more months. So now, after 3 more months, what I need to do is we need to deposit this money. So this is the first quarter, the second quarter. Then we need to calculate this for the third quarter. So I'm going to multiply 1,060.9 to the additionally 1.03, right? I'm going to get my money back plus the 3%. So let's multiply this, 1.03. It is going to be equal to the 1,092.72, roughly. So in the last quarter, in the quarter number 4, we can calculate this now. So 1,092.72 times to the 1.03, right? So my money back plus the 3%. So if I would just multiply this 1.03, I would get $1,125.5. So this is what we will get at the end. So this X here is going to be $1,125.5. So you see, so we've got more money than if I would just invest the money into the bank A. So in the bank A, after 1 year, I've got 1,120. So even though it was super easy to calculate this money, um, So I've got less money. So probably, so this calculation's worth to have more money, right? So now there is a natural question is that, hey, so if I would just like said if the bank B is simply increasing the period, the interest period, then I'm able to get more money, right? So why don't we just increase this, not like 1 quarter, but to why don't we do this like every month? So let's say the bank C is offering again 12%, okay? But it is going to it calculates the percentages, calculates the interest every month, okay? So in this case, how to do the calculations? So again, I'm going to invest 1,000, right? Every month I'm going to get per 1%. So after 1 month, it's going to be 1.01. This is the 1%. After one more month, it's going to be 1.01. After one more month, 1.01, and so on. And I have to multiply this as a 1.01 12 times. And this is going to be simply equal to the 1,000 times to the 1.01 in the power of 12. So let me do this using a calculator. So 1.01 in the power of 12. And I have to multiply this to the 1,000. And what we'll get is $1,026.82. So this is even more than before, right? So before it was 1,125. Okay, you see, so if I just increase the interest periods, then I will get more and more money. So let's figure out the general formula. You see, so I'm just like multiplying this to the 12 times. If the interest period is 12, if the interest period is 4, then I have to multiply my found actually 1,000 is multiplied to the 1.03 once, twice, 3 times, and 4 times, right? So it basically tells me that hey, if you have got the 1,000, right? What you have to do is you need to multiply this to the percentages n times, where n is going to be the interest period. Interest period. So do you remember this percentage is going to be obtained by 1 plus the yield percentage P divided to the n, right? So essentially, if the yearly interest P is going to be the yearly interest, So in our examples, P was always 12%, right? Which is going to be 0.12. And we've considered the different n's. So when n is equal to the when n is equal to the 1, for example, then what we have seen before is that this formula is going to be in this way. So if n is equal to the 1, then this formula becoming 1,000 times to the 1.12 in the power of uh, 1 simply, right? So this is the amount of the money which we'll get after 1 year. So if n is equal to 4, so essentially the interest period is equal to the 4 times per year. So this is going to be 1,000 times 2 here. So the p is equal to the 0.12 divided to the 4 is 0.03. If I add this to the 1, it's going to be 1.03, and I have to multiply this into the 4. So this is what we've seen before here, right? So I multiply this 1.03 4 times. So if my money would be calculated 12 times per year, so if n is equal to the 12, then this is going to be 1,000 according to this formula. So this is very important formula, it appears. So I'm going to mark this formula. So again, so you need to multiply this as a 1,000 times 2. 1 plus, so 12%, so P is going to be 0.12, is divided to the n, which is 12. What you get is 0.01, so that is why it's going to be 1.01, and this should be in the power of n, which is 12, okay? So if you remember, I've got here 1020, here 1025, here it's 1026 or 1100, sorry, always. So it was 100, 1120, 1125, $1,126 correspondingly. So what I've got is this formula. So I would like to know, hey, if this n is increased a lot, so it goes to the infinity, does my money is going to be increased as well? So what if my bank is going to calculate this not just like 12 times per year, but maybe every week it's going to be like 52 times, or maybe every day is 365 times, or maybe every hour, which is going to be 8,760, or in every minute, which is going to be 525.6 hundred, 525,600. So you see, so in order to calculate all of these numbers, so it's I think the number which we will get at the end, so this number is has a limit. And I would like to figure out that limit. In order to do this, I'm going to calculate a special formula. So this is going to be 1 plus 1 over n the power of n. Okay? And I would like to do this for the different values of the n. If n is equal to the 1, for example, just substitute 1 to here and to here. What you get is simply 2. So now let's assume that n is equal to the 10. So in this case, I'm going to substitute the 10 to here. It's going to be 1.1, right? And the power of 10, which is going to be roughly equal to the 2.59. So what if n is equal to the 100? So if n is equal to the 100, it's going to be 1.01 because now it's going to be 1 over 100. So 1 divided as 100 is 0.01. If I add this to the 1, it's going to be 1.01. And this is in the power of 100 is going to give me 2.70. So if I would just continue this, and if I would just calculate this to the 1 million, then it's going to be 1 point, essentially lots of zeros. So 5 zeros, 1, 2, 3, 4, 5 zeros, and 1. And this is in the power of 1 million with 6 zeros. And this is going to be equal to the 2.7182. Okay, so this number is a magic number. We call this as the natural exponential number. So natural exponential number. And it appears this e, the natural exponential number, is defined as the limit of 1 plus 1 divided to the n in the power of n when n goes to the infinity. Right? So the only problem is how it is connected with our problem of the compound interest formula or the interest formula. So again, I will go to the problem of the compound interest formula. So the compound interest formula. So if you remember, the formula is what was like this in this way. So essentially A, the amount which we'll get after some period of time is going to be equal to the P times the 1 plus P, or let me call this as A0. A0 times the 1 plus P divided to the N. And this is in the power of N divided to the T. Okay, so it was just simply N here in our previous formula. I'm just decided to multiply this to the T, where T is going to be the years. Okay, so again, so let me write it. So P is going to be the yearly interest. So the previously it was 12%, so that is why 0.12 interest. So the N is going to be the period, interest period, interest period. So essentially how many times it is going to be calculated. So this percentage P is going to be calculated per year. So you see that even though at the sum, the yearly interest is going to be the same, depending on the number of the recalculations, you might get more money at the end. And the T is going to be the amount of the years, amount of the years. So the T might be 1 year, 2 years, 3 years, and so on. So now, for this formula of the compound interest, do you remember what we did is, I would like to invest $1,000. So the A0 is going to be $1,000. And I see that if the bank would just recalculate my interest lots of time per year, maybe like 1 million times, then probably I would get a lot of money, right? So I would like to understand, hey, so if n is a huge number, so the 10 in the power of 6, is there any simple formula to calculate how much money I will get? It appears yes. So in order to do this, I'm going to make the notation for this formula. So let's calculate. So let's denote 1 over k to be equal to the p divided to the n. So from here we can obtain that the k is equal to the n divided to the p. And from here we can obtain that the n is equal to the k times to the p. So I'm just going to substitute this to the formula back. So it's going to be a is equal to the a0 times to the 1 plus. So do you remember what was the p over n? P over n is equal to the 1 over k, right? So it's going to be 1 over k. And this is in the power of nt. So nt is essentially is kp times to the t. So the k times to the p times to the t. Good. So what I would like to do now is I would like to rewrite this in a slightly different way. So the a is equal to a0 times to 1 plus 1 over k in the power of k, right? And this is in the power of pt, okay? So do you remember? So this this is allowed to do, okay? So if you remember, we said, hey, so I would like to figure out what is going to be my amount if this n is going to be increased a lot. So if n goes to infinity. So if n is increased, k is also going to be increased. So essentially, if n goes to infinity, k is also going to infinity because they are proportional. So essentially, so I know that this term in the limit when k goes to the infinity is going to be equal to simply to the e, so which is 2.7182. We've just seen this before. So I'm just going to substitute this to here. So a is going to be equal to the a0 times to the e in the power of pt. So this is how I'm going to calculate the compound interest if I will just so if my bank is recalculating me the interest in a continuous basis, so essentially every second maybe. Okay, so let's do an example. So let's say you have deposited, so example, you have deposited $20,000 to the bank with a yearly interest 6%. So 6% is the yearly interest. Okay, so now let's assume that the bank is going to recalculate your percentages continuously. What does it mean? It means that the bank is going to calculate my percentages every second or every millisecond. So I would like to know how much money I will get after 5 years. Okay, in order to do this, I'm just going to use this formula. Okay, so this formula tells me that, hey, my initial fund is equal to the 20,000. So the P yield percentage is 6%, which is going to be 0.06, right? So this is equivalent to the 6%. And one way to get this is going to be 6 divided to the 100, okay? So this is going to be 0.06. So the T in our case is equal to the 5. So I'm just going to put everything here to the formula and calculate everything. So the amount which we'll get after 5 years is going to be equal to 20,000. So according to this formula, 20,000 times to the e in the power of 0.06 times to the 5, which is going to be equal to the 0.3, by the way, right? So this is going to be 20,000 times to the e in the power of 0.3, and you can use a calculator and calculate everything out. So this is going to be equal to the 26.99718 dollars. So essentially here there is a decimal point. So 26,997.18 dollars. So this is what we can get from the bank if the bank would calculate the percentages continuously. So again, so you see, so the knowing the value of the E, which is going to be equal to 2.7182, it's really important because we can calculate the compound formula. So essentially, the interest, which can be calculated in a continuous basis, so every second or every millisecond. Thank you. So hope this video lecture was very useful for you.